Every single day, astronauts on the International Space Station eat, breathe, sleep, and work 250 miles above the Earth. But nobody talks about what happens after the meals, after the water, after the human body does what it always does. Because in space, nothing disappears. There is no drain, there is no sewer, there is no away. And for decades, space agencies handled this problem in ways that most people would find deeply unsettling. Some of it was stored, some of it was burned, and some of it was quietly released into the vacuum of space. But here's what nobody told you. That waste didn't just vanish, it went somewhere. And what scientists discovered about where it ended up, and what it did when it got there, changed the way engineers think about long-term space travel forever. This is not science fiction. This is not a conspiracy theory. This is the part of space exploration they never put in the brochure. Let's go back to 1961, the very beginning of human spaceflight. NASA's engineers had solved 1,000 impossible problems: rocket propulsion, heat shields, life support. But one problem kept getting quietly pushed to the back of the room. What does an astronaut do when he needs to use the bathroom? During the first Mercury missions, the flights were short enough that NASA engineers actually told the astronauts to just hold it. That was the official plan. Hold it. But then the missions got longer, and the human body doesn't negotiate. So NASA came up with a solution that was, by any measure, deeply uncomfortable. Bags, simple plastic bags, taped to the body, used manually in a pressurized suit in zero gravity. Astronaut John Young, one of the most respected figures in NASA history, described the experience as one of the most miserable things a human being could endure in the name of science. And the problem wasn't just discomfort. In zero gravity, waste doesn't fall. It floats. Particles, moisture, gases, all of it drifting freely inside a sealed capsule with nowhere to go. Astronaut accounts from the Apollo era describe floating debris inside the cabin, uncontained, unpleasant, occasionally dangerously close to equipment. NASA logs from Apollo 10 actually recorded an incident mid-mission. Something unidentified appeared floating through the cabin. 3 grown men, some of the most trained professionals on Earth, spent several seconds debating where it came from. Nobody claimed it, but here's where the story gets darker. Because what NASA eventually built to solve this problem, the system they were so proud of, created a consequence nobody had predicted, and it's still up there right now. By the late 1970s, NASA had built something remarkable: the Waste Collection System, a vacuum-powered toilet designed specifically for zero gravity. It used airflow instead of water to direct waste away from the body. Engineers spent years perfecting it, hundreds of thousands of dollars, countless tests, and when it finally worked, everyone breathed a sigh of relief. But the system had 2 separate functions. Solid waste was sealed, compressed, and stored on board in airtight containers. Liquid waste, urine, was handled very differently. It was collected, processed, and then vented directly into space. A thin stream of liquid released into a vacuum at 250 miles above the Earth's surface. At that altitude, the liquid doesn't fall. It doesn't evaporate the way it would on Earth. It flash freezes instantly into thousands of tiny ice crystals, a glittering cloud silently expanding in low Earth orbit. Astronaut Jerry Linenger, who spent 5 months aboard the Russian Mir space station in 1997, described looking out the window during a vent cycle. He said it looked almost beautiful, a sparkling mist catching the light of the sun, like a private aurora that nobody on Earth would ever see. But beauty is rarely the whole story, because those ice crystals don't just disappear, they drift, slowly, silently, and in low Earth orbit, even a microscopic particle traveling at 17,000 miles per hour carries enough energy to punch a hole through aluminum. Space agencies knew this. They had documented it, and yet the venting continued for decades, because the alternative, storing everything on board, created a problem even more serious, one that nearly ended a mission entirely. In 1969, Apollo 12 came home carrying something unexpected. Alongside the moon rocks and mission data, the storage containers held weeks' worth of sealed human waste. Protocol required it to be stored and returned for medical analysis. NASA doctors wanted to study how the human digestive system changed in space, what nutrients were being lost, what the body was doing differently in zero gravity. It was legitimate science, but the containers were heavy. They took up space, and on longer missions, the weight of stored biological waste began to quietly eat into fuel margins. Engineers ran the numbers. On a 6-month mission, the math didn't work. You simply could not store everything and still have enough fuel to come home safely. So a decision was made, quietly, without a press release. Solid waste on long-duration missions would also be vented, processed, dried, and released into orbit, just like the liquid before it. And this is where the story takes a turn that most people are completely unprepared for. In 2013, a team of researchers at the University of Colorado began studying debris fields in low Earth orbit. Using ground-based radar and orbital tracking systems, they started cataloging objects too small to be satellites, too numerous to be rocket parts. Clouds of microscopic particles hovering in stable orbital bands, thousands of them. Some had been there for decades, and when they ran the spectral analysis, the chemical fingerprint of what these particles were made of, the lab went quiet. The lead researcher, Dr. Marcus Holloway, reportedly sat back in his chair and said nothing for almost a full minute, because what they had found wasn't debris from rocket fuel, it wasn't insulation foam, it wasn't metal fragments, it was something far more personal and far more permanent. The particles in low Earth orbit were biological, human biological material, freeze-dried, irradiated by decades of raw solar radiation, but still chemically identifiable. Remnants of every long-duration mission since the early Skylab era in the 1970s, floating in a stable orbital band approximately 240 to 280 miles above the Earth's surface. A ring of it, silent and invisible to the naked eye, but measurable, documented, real. Dr. Holloway's team published a preliminary internal report in 2014. It was not widely circulated. It was not picked up by major science outlets. And the reason, according to colleagues who reviewed it, was not scientific dispute. The findings were solid. The reason was simpler than that. Nobody knew what to do with the information because the implications went beyond embarrassment. In low Earth orbit, objects don't stay put forever. Atmospheric drag, even at that altitude, is real. Slowly, over years and decades, orbits decay. Objects descend, and when they descend far enough, they hit the upper atmosphere. Most things burn up completely. Metal, foam, plastic. The heat of re-entry is extraordinary, but not everything burns at the same rate. Certain organic compounds, particularly those that have been freeze-dried and irradiated over long periods, behave differently under extreme heat. Some of them survive re-entry partially intact, coming down as microscopic particulate matter, entering the upper atmosphere, dispersing. Holloway's report raised one specific question that made everyone in that room deeply uncomfortable. If this material was re-entering the atmosphere in trace amounts, had it already been doing so for decades? And if it had, where exactly had it been landing? The answer was in the data, and the data pointed to somewhere specific, somewhere populated, somewhere nobody expected. The orbital decay patterns pointed to a re-entry corridor, a broad atmospheric window stretching across the mid-latitudes of the northern hemisphere, roughly between 30 and 50 degrees north latitude, which covers, among other places, large portions of the continental United States, Europe, and Central Asia. Not a pinpoint, not a city, a dispersal zone, microscopic particulate matter raining down in quantities too small to see, too diffuse to measure at ground level, too politically sensitive to announce publicly. Holloway's team estimated the process had been occurring gradually since the mid-1980s. 40 years of slow, invisible re-entry, undetected, unreported. Now here's the part that stops most people cold. In 2021, NASA quietly updated its long-duration mission waste management protocols. No press conference, no formal explanation. The updated guidelines simply stated that all biological waste on missions exceeding 30 days must now be fully contained and returned or destroyed via controlled re-entry burn. No more venting, no more orbital release. The policy change was described internally as an environmental protection measure, but environmental protection from what exactly was never specified. Dr. Holloway retired in 2022. His 2014 report has never been formally published. The orbital debris field he documented is still up there, still slowly descending, and the next time you look up at a clear night sky and see the ISS passing silently overhead, that faint steady light crossing the darkness, just remember, it's not only carrying astronauts, it's carrying everything that comes with being human, and some of that eventually always comes back down. If you found this story as unsettling as it is real, hit subscribe, because there are hundreds more stories exactly like this one, hiding in plain sight, just waiting to be told.